The surface of Venus is cracking and moving like an ice floe on the ocean, likely due to tectonic activity. This is what Paul Byrne, Associate Professor, Planetary Science, North Carolina State University, says. This is on The Conversation. The big idea? Much of the brittle upper crust of Venus is broken into fragments that jostle and move, and the slow churning of Venus's mantle beneath the surface might be responsible. Venus is also known as Earth's twin because it's just about the same size. He says, my colleagues and I arrived at this finding using decades-old radar data to explore how the surface of Venus interacts with the interior of the planet. We describe it in a new study published in Proceedings of National Academy of Science on June 21st, 2021. Planetary scientists like me have long known that Venus has a plethora of tectonic landforms. Some of these formations are long, thin belts where the crust has been pushed up together to form ridges or pulled apart to form troughs and grooves. And in many of these belts, there's evidence that pieces of the crust have moved from side to side as well. In our new study, we show for the first time that these bands of ridges and troughs often mark the boundaries of flat, low-lying areas. Kindly support my Patreon account since YouTube has again demonetized my YouTube channel. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below. Ridges and troughs of boundaries of flat, low-lying areas that themselves show relatively little deformation and are individual blocks of Venus's crust that has shifted, rotated, and slid past each other over time that may have done so in the recent past. It's a little like Earth's plate tectonics, but on a smaller scale and more closely resemble pack ice that floats atop oceans. Researchers have hypothesized that just like Earth's mantle, the mantle of Venus swirls with currents as it's heated from below. My colleagues and I modeled the sluggish but powerful movements of Venus's mantle and showed that it is sufficiently forceful to fragment the upper crust everywhere we found these lowland blocks. Now, why does this matter? The major question about Venus is whether the planet has active volcanoes and tectonic faulting today. It's essentially the same size, composition, and age of Earth, so why would it be geologically alive? But no mission to Venus has yet conclusively shown the planet to be active. There's tantalizing but ultimately inconclusive evidence that volcanic eruptions have taken place there in the geologically recent past and are perhaps even ongoing now. The case for tectonic activity, the cracking, breaking, and folding of the planet's crust is on even less solid ground, showing that Venus's geological engine is still running would have huge implications for understanding the composition of the planet's mantle, where and how volcanism might be taking place today, and how the very crust itself is formed, destroyed, and replaced. Because our study suggests that some of this jostling of the crust is geologically recent, we may have taken a big step forward in understanding if Venus really is active today. What is still not known? It's not clear just how widespread these crustal fragments are. My colleagues and I have found 58 so far, but that's almost certainly a low estimate. We also don't yet know when these crustal blocks first formed, nor how long they've been moving around on Venus. Determining when the crust fragmentation and jostling occurred is key, especially if planetary scientists want to understand this phenomenon in relation to the planet's suspected recent volcanic activity. Figuring that out would give us vital information on how the planet's surface features reflect the geological turmoil within. So what's next? This initial study has allowed my colleagues and me to make our best guess yet about how Venus's vast lowlands have been deformed, but we need much higher resolution radar images and topographic data to build on this work. Luckily, that's exactly what scientists are going to get in the coming years, with NASA and the European Space Agency both recently announcing new missions bound for Venus later this decade, it'll be worth the wait to get a better understanding of Earth's enigmatic neighbor. And we also know that we have this huge asteroid, comet, or mini planet coming in from the Oort cloud. Well, they think it's from the Oort cloud. It may be just another interstellar minor planet. And in about 10 years, it would have reached Venus. And now, what effect will that have on Venus and our Earth? We have no idea. That's another surprise in our solar system. This is Here from the Conversation. Please leave your comments, and thank you for your support.